Hi, everyone, and welcome to our talk. My name is Max Körbächer.
And my name is Alexa Griffith. I'm a senior software engineer at Bloomberg working on their AI platforms.
And today we will have a little exploratory journey throughout the platform engineering GenAI universe. Our idea behind is like, either you pick up little items out of this whole universe, or you see a full-blown large platform. But you never see the journey in between and how you maybe come from one thing to the other thing. And that's how our journey will start for also today. We would like to go step by step through some little ideas. We'll get you set up. And then we'll dive into one to other demos, show you a few little things. And yeah, we'll round it up in the end.
Sounds good.
So this map you maybe know. And usually you know this way more bigger landscape from the Cloud Native Computing Foundation. But this is a specialized map just showing the AI landscape from Kubernetes and the CNCF universe. The very interesting thing is, it's actually kind of small. So AI happens with Cloud Native, but it also happens alongside of the Cloud Native universe. What I mean with this is like this beautiful map. And that's actually insane, and it's old. 2023, but it's also great because you can see different blocks in it. You see infrastructure, you see data analytics, you see also the open source layer, which is like on the bottom, this kind of greenish area. Now, keep your eyes on it. Don't blink, because there will be a little change between 2023 and 2024. It almost feels like it's exploded, right? I'm still waiting for the 2025 version. I would love to bring it here, but I believe there's so much changes on the market that the guys who have built this map need a little bit more time. But why this map is now relevant to us is that we need to understand we live in a cloud-native ecospace, and everything is moving fast. We have a lot of open source projects, a lot of things going on, but we very often talk about the same things, where yes, you find also a lot of commercial solutions for sure, but it also means there's a total other entire ecospace that we maybe haven't thought of yet, or maybe have already provided solutions, right? So Kubernetes platform engineering needs to bring in some kind of flexibility of allow us to adopt to all of these very fast changes, with these very fast explosions on the market, and maybe also roll out some of the market player which we can see. And Kubernetes is therefore the perfect platform because it knows already from 2020 some of the automation hype. Then we go to Edge, IoT, telco last year, and always about internal development platforms and stuff like that. And this year, if you look into the schedule, similar to our talk, at least every second talk has something with AI written in it. But the reason for it is not just because it's a hype, but we provide with Kubernetes and platform engineering actually a very good foundation to drive this kind of innovation and provide also an environment to frequently change some of the tools which maybe got outdated because something new or fancier popped up into the market. Not saying that this is a good thing, but it's something we should consider. On the other hand side, and that's why platform engineering becomes so relevant in this area, is that we do not just have this infinite DevOps cycle. If you look closely to the image, you can see that there's at least, I would say, 3 to 4 infinite DevOps cycles, which also all are interconnected. And that complicated the way how we're working, how we're integrating tools dramatically. It comes from just you build it to run it, to you build it, you run it, you find and to maintain your data, and then you need to help others to use it, to integrate it with your AI applications, to provide LLMs, and so on and so forth. And this puts us to the big question, what are my options to run GenAI workload and to enable others to use them too? Because what we also can see is that very clearly, not every role in the market is specialized in utilizing open source and going through the whole stack. If you're a data scientist, you build it, you run it, doesn't work anymore. You're a specialist in something completely different, and that's where we come in to bring an environment where we can help offloading some of the complex environments of the complex integrations and make the life of someone else easy. And that's where we start our journey. So for this one, we talk about the TVP, the Thinnest Viable Platform. And as you can see, we're swimming here in a little rudder boat. I don't know if this is the right translation from my German brain. But it helps us to get around. It does its things. We do not think. That's a good start. How does it look like in the platform engineering perspective? This little thingy for getting around is actually quite big. Just to provide a platform and integrate well with some cloud provider like AWS. If I talk with my team about it, we dream about something like that one. The cool thing is, with open source projects like Canoe, we get the things more or less easy, fast up and running. For sure, we need to tweak, for example, the key cloak to be integrated with our corporate environment. But everything else is coming more or less out of the hand. And also in this rather complicated setup, we can also throw out, for example, crossplane or Argo workflows to simplify it in some way. We also maybe don't need backstage, but we maybe also would like to provide backstage to make the entry point very, very easy for spinning up an inference service. And we'll look into this tool later a little bit more. However, with this tool setup, we can start in a very, very fast way to provide a first environment to work within. Not sure if the video plays now. So normally I would like to play you a video, which would show the setup. So actually to prevent that the daemon gods screw up this talk, we thought like we are smart and pre-record something. Looks like the pre-recording daemons also set up this thing and make it a little bit bad for us. Actually what I'm going to show you in the short demo, you can just imagine that we run a CNOA deployment, and you can see that after some while, we have the setup of all the different applications that are needed for running our platform. We see our Git Argo CD being integrated. We see the deployment of the, maybe we'll get this done. We see that we, after a couple of minutes, can go into the Argo CD and see also that everything else getting deployed. We will have the backstage, we'll have the cert manager, we have the external DNS who automatically starts integrating with the load balancer and setting up also the routes for the machine so that we can, after 15 minutes, roundabout, reach our first services. And that makes it for us very simple in the beginning to get the things running. And so from here, we move on to our MVP.
Thank you. OK, so for our minimal viable platform, we'll start with talking about KServe for serving inference in our GenAI platform. So KServe is an open source tool that simplifies AI model development on Kubernetes by extracting away the complexity of Kubernetes. It allows developers to focus on models rather than worrying about all the configurations you need to run your AI models. So it supports multiple GenAI and ML frameworks, making it versatile and framework agnostic. In the past, we currently have a unified API that also supports OpenAI. So also what's great about KServe is that it integrates with other open source tools easily and provides a lot of out-of-the-box features. So KServe has been serving predictive inference for a while now, and these are all of the features that have come out of the box with that. With GenAI, we'll add some more, but these are the basic features that come even with predictive inference. So the ability to scale up and down from 0, request batching, security, distributed tracing, auto-scaling on GPU and CPU, logging, different observability, and traffic management. So with GenAI has come a host of new challenges, and in order to tackle those and accommodate these, we have added a few new and upgraded features. So adaptive scaling, now we can do, there's built-in token-based auto-scaling for our GenAI models. Also performance boost with model cache and prompt cache, so this minimizes our latency and our ability to quickly use a model that's already been downloaded rather than have to download it again. Also, again, like I mentioned, we have OpenAI protocol support, and we also have scalable inference. So as models grow larger, we need to sometimes serve them on multiple nodes with VLM, and this gives us high-performance workloads. Additionally, and we'll talk about this in a bit too, is our integration with the AI Gateway project. So we connect seamlessly with our managed AI services, giving us a better platform.
And KServe, for example, is a perfect example where we can say, like, hey, look, we can provide you, for whatever position you are, a template within Backstage where you can see the inference service on the bottom. So this will pop up in your front end. And if you're, let's say, team A, you would like to have the first inference service just for yourself deployed, you will go into Backstage, just fill out the basic information. Who's the owner, which namespace, for example, it should be deployed, can be also cluster, whatsoever. And you can also fill in like some more specifications about it, like different models, whatever you would like to have. And through Backstage and the automation process, you're going to go and deploy it, for example, in the inference cluster. The cool thing is it obviously will also work with other services. So it doesn't matter if you use KServe, LLM, or if you even would like to implement some other use cases, for example, creating a new tenant in Milvus vector database. So what it allows you is that you can bring really the self-service for a team and being autonomous, integrating their learnings, their models, and giving them, for example, the space in a database or space in an S3 bucket just out of a Backstage portal.
Yeah, and I also like how this slide shows how easy it is to set up a service using KServe. You have a very small YAML, and you can get something up and running and have all the features that we just discussed. So I want to talk about another component, and I'll show how this all fits together next. Envoy AI Gateway. It's a new open source tool built from the Envoy Gateway project that we've been working on, and it adds features to better serve AI workloads, especially as a platform team. So it's built by the collaboration of Tetrate and Bloomberg engineers, and it offers, in the MVP, centralized access, so a standard, controlled, and audible way to access both self-trained and open source or commercial models. It also provides a way to manage credentials between different LLM providers and on-prem, and it offers out-of-the-box cost monitoring tuning specific for your GenAI workloads, like token-based limits and token-based cost optimizations. So this is a diagram of how the platform would fit together with the components that we just mentioned. So let's say you hit a load balancer, and then you'll hit the Envoy AI Gateway. So you'll get these are just a few of the features that I mentioned. So as we know, different LLM providers might have different access patterns, which is super nice about this is from the client's perspective, they just need to know one access pattern to hit Envoy AI Gateway, one centralized authentication method, and under the hood, the Envoy AI Gateway will route you to the correct provider. So this is an example of what your platform could look like in a hybrid environment with a managed inference cluster and using an LLM provider. So we have a demo. I hope it works. We'll see. But anyways, what it will show is using an AI agent to call a tool to get the whether this is what a platform could look like architecture when you do that. So you can easily use the Envoy AI Gateway to have your agent route to either a managed inference Kubernetes cluster or something like AWS Bedrock. Oh no. Well, there is a video here, but it's not showing up.
Maybe while we are fighting with the demon gods, demo gods, not demon gods, whatever.
Same thing.
Are there already some first question about like the platform engineering part? How does it enable the AI or GenAI workflows? Anything that? Any questions there? Maybe on Canary or Backstage, Argo, how the deployment works. If you're shy, it's not a problem. You can run to the microphone. It's hidden in the shadows. No one will see you. Give you the chance to still ask awesome questions.
Are you aware of any example like Canary with KServe? Is there anything out there?
Yeah, so the question is if there's any example with scenario with KServe. I haven't seen one. I would like to work on one, or would like to provide it to this one. Actually, the interesting part is when you deploy KServe, it most of the time to run very, very good requires some part of Istio. So you have very strict dependencies coming together, right? And that's the one downside of it. So if you want to run the KServe inferencing model, you have to go this way. So maybe you would prefer VLM or some other setup. But if you're fine with that dependency, it's obviously a very good choice. The thing is why we use it here is like the setup itself is kind of easy. You just deploy it, it's cluster-wide available, and it reacts very simply on an inference service that you drop in for Backstage, for example. So it makes the life very easy to get the first services up and running. Any other question? All right. During the Mac is starting, I would like to dance or something.
Tell a joke.
Most frequently, LLM you guys run usually?
Well, that depends on. So the question is which LLMs are used most frequently. I first answer shortly this question. Yeah. It depends on. I cannot answer this question for Alexa's organization, but what we see is like in the integration and the demo which we have running, we use, for example, AWS Bedrock and just enable Claude, for example. But it doesn't matter. You can also have ChatGPT running or set up your own ones, like the Llama from Facebook, right? So it's very flexible. But this is then also the power of the API gateway, which Alexa shows, that you can just play around with the different LLMs and just exchange them as you need it, because you have a gateway in between who orchestrates for you all the other complexity away. And that makes the integration very easy. Please.
That gateway is ready, like for production ready? Is it, we can just use it?
I think that's more a question for you.
It's getting there. It's very close. You can check out the Envoy AI Gateway project. It's under Envoy Gateway, and yeah, we just announced it at KubeCon NA, and I think we had a big release that came out about a month ago. But we're definitely expecting people to come into the community and help us run it as well.
Thank you. Yeah.
In short, there's always room for more contribution to it.
But in the demo, I hopefully will show you how it is to use it. So.
Yeah, we will put up the slides later on to the SCAD, and then you can find the slides and the links to the videos, so that you can also rewatch the demos. Some of the demos are quite easy and simple, right? It's just like a wrap-up of like how does it look like if you deploy an infrastructure with Sinui. Alexa's demo is a little bit more complicated than that. And then we would have also a third one looking into like how we enable through OpenTelemetry and OpenLLMetry the observability for large language models, and how does it forward it to any kind of your preferred open observability tool.
Nice. Okay, awesome. Thank you, guys. So here we have a pretty basic agent. I'm going to run it locally. It's going to ask, what's the weather like in New York City? It's going to call to the LLM running in Bedrock. It's going to get a response, and that's going to say, hey, use this tool. And it's going to go use that tool and give us a response. So yeah, let's look at how that would happen. So first I just want to, and I'll actually pause it here. I just want to show, so this is using the Envoy AI Gateway. I just inspected one of the resources, and you can see here that we have a backend set up, and it shows we have a KServe LLM backend, which the value is dsp.llama, and then we have an Envoy basic AWS backend, and it's eu.anthropic. So that value is what we're going to use in our requests, makes it super easy. I'm going to port forward to the Envoy service, and I also just want to show you the namespaces we create. I have a Kind cluster running. This is what the AI gateway creates, so we're port forwarded. Now we are going to show how we can run our agent and get a request back. So here we're hitting DSP, Llama, blah, blah, blah. That's our on-prem Kubernetes self-hosted service. And I'm also going to hit AWS Bedrock and also get an answer. Now, I'm using Claude, Anthropic, and I'm also using Llama, so we get slightly different results, but same idea. Also, I want to show with just a very small config that was super easy to do, I get out of this out-of-the-box cost monitoring as well. So that shows just how easy it is with the same endpoint, just given the setup, the value is the name. And we could easily manage routing to both on-prem and using an LLM provider like AWS. But we'll have to do that one more time.
Right there?
Yeah, there's one more. Not right now, but later. We'll see. Yeah, thanks to the tech guys. That was really great. Okay, so with predictive inference, it's common for users to manage their own models, train them, everything. But now it's also popular to use these out-of-the-box, open source or vendor LLMs. So this has changed our perspective of an inference platform a little. So now we look towards a solution as a platform team more focused on managing LLMs and providing them as a service to our users. So what we want to do is provide AI without the overhead. Give users access to state-of-the-art, updated LLMs like DeepSeek, Llama, Anthropic, et cetera, without deploying or maintaining them. We want to provide centralized access. So we want an AI gateway that abstracts all of these model management complexities, making AI as simple as a consistent API call. We also want to give optimized performance with curated and up-to-date models. We want to be able to manage these models well and focus on, so our users can focus on innovation and not the infrastructure underlying it. Additionally, we want to build it with Kubernetes native, cloud native principles to ensure that we're efficient, cost-effective, and flexible. So let's dive into stage 3. Now we've upgraded from a nice sailboat to a spaceship, and we are going to talk about our advanced features like intelligent load balancing, observability patterns, and different techniques for optimizing our LLMs. So expedition mode. As we're thinking of LLMs as a service, right? I just showed you the architecture. Where a user could hit, an inference, a self-hosted model, or something like on AWS. Well, additionally, we want to make our platform as easy to use. We want to make it optimized for performance as well. And as a platform team, we want to be able to give users different options. So some workloads can be done in batch. They don't need real-time processing. It's not critical that they have that. Therefore, having something like a batch inference platform with these open source tools, the same open source tools that we use to create the other platform, can greatly help with our resource utilization and costs. And this is an example of an architecture of how you, as a platform team, can provide that to your users.
So, as already teasered, there's also obviously, we need to have deeper insights about the models, how they're doing, getting feedback from the system, maybe even see the traces, because you sometimes see how the tools are communicating with each other, especially if you chain a few of those models together. You're very, very interested in what's going on and where I'm actually losing a lot of time, maybe because I need to optimize the request, maybe I need to choose a different model giving me a shorter answer, whatsoever. How do I get that? Well, on the one hand side, I can use OpenTelemetry. This gives me the broad, big picture, but OpenTelemetry doesn't not yet completely understand what's going on with a large language model. It doesn't understand the specifics, the details of it. And there's a nice development around that called the OpenTelemetry hope I spelled it right, that integrates with different models, but also with different platforms. So we do not just talk about like using, for example, Claude or ChatGPT, but also utilizing something like a Bedrock or Pinecone or whatsoever. But from there, it just grabs the information and put it over to the good old OpenTelemetry and just forward it to our favorite endpoint. Whatever it is, might be a commercial solution, might be an open source solution, might be something which I have developed by myself. And there's another video.
Oh, nice.
Perfect.
Wow.
So this is, for example, something with Bedrock integration. In this case, we have ChatGPT in the background, and you can see different stuff like costs. You see the amount of requests which we do, how long is the average duration. But you can also see that we have a lot of service quality and guardrails implemented. And this is just on the basic information which we get back from the observability integration, and we put some guardrails around it. And last but not least, we also can see how prompt caching can help us to optimize, for example, the performance and how much time we can save. And yeah, I mean, $9 saved or not, that's not the big difference, but it depends on how much we have in the end running here. So this is a very simple demo. The guardrails are very easy. It's just like if we get a negative feedback, we just say like, okay, maybe either it's toxic or it leaks something. But from the information which we receive already from OpenTelemetry, we can use that to directly instrumentalize it and give it back to the developers, to the engineers who would like to maybe see that, right? Especially if we are working with the models and try to integrate and set up something that's in the end, useful and should go into production, so we have a good cycle overall.
Nice. So this is an advanced view of running KServe at enterprise scale, the type of components that you may have. And I'll try to go through this quickly, but one is model caching. So a DeepSeek model is around a terabyte, and if we have an H100 node, we have about 640 gigabytes of storage. So we're running into situations where it might not fit on a single node. So model sizes are growing, and that's for multi-node inference, sorry. So that's why we're also offering multi-node inference serving. For model caching, again, models are also growing bigger, so the download time takes a while as well. So model caching helps us to reduce that cost of downloading the model every time a pod starts up. Additionally, we have prompt caching. So KV cache is something that comes out of the box with VLM, and it helps us to optimize our prompt caching when on the pod as well. Okay. And that helps us also to, all these caching, especially model caching, helps us to auto-scale quicker also. Okay, so model caching. This visualization is an example of the time that caching a model will save. So let's just say, for example, you have an init container that comes up. You want to auto-scale. You need to serve more requests. You're getting more requests in. You want to scale your service. And your pod comes up, and it needs to download the model. That takes 12 minutes. The rest of the time, let's see, that takes like 3 minutes. But if you have a local cache of your model saved, what's nice is that we can just get rid of this bottleneck that takes so long, and we can now auto-scale a lot quicker and serve our requests a lot better. Also, there's a KV cache growth challenge. So KV cache expands exponentially with sequence link, as we can see. So another solution that we are implementing is the LM cache. So it's also an open source system designed to manage your KV caches efficiently. It makes KV caching more scalable. It does this by caching common input prefixes to reduce your redundant computation, speed up repeated queries. So it also makes access and storage of caches faster, especially for long documents and multi-turn conversations. It's nice because it can share and store across multiple VLM instances and route queries to the instances that already hold the relevant context for your KV cache. So this has been shown to be able to reduce the time to first token by around 3 to 10% and save on the GPU cycle. One more advanced feature that we are looking into is the GenAI is to helping with disaggregated serving. So GenAI inference latency isn't always predictable because we have these two steps, the prefill and decoding one. One's compute bound and one's memory bound. So what we can do to optimize this is to separate the two and execute them independently and have two different sets of GPUs that can handle them, therefore increasing our throughput and optimizing our hardware performance. So we want to optimize both performance and latency here.
So with that, we are at the end of our journey. Like a good hike, sometimes it gets a little bit windy, stormy, and a little bit challenging. So maybe it's not really the end also for this one. What we wanted to show is like in the end, like on the way, you will find all the time something that maybe can be improved, that we can go up for the next challenge, that maybe needs to be replaced, right? Sometimes replacements are not worse, they are part of improving things. If you keep with the things that you have implemented in the past, well, it's not always something that sustains forever. And that's what we want to demonstrate with having platform engineering as an enablement platform, also to bring up more complex topics around GenAI, easily implementing an AI gateway, and so on.
Yeah, totally agree. Thank you.
Thank you very much, and enjoy the rest of the KubeCon.